Our next speaker is Carla Sharpe from Soreo. She will be speaking on the African VLBI network. And Carla manages the program of developing and building the African VLBI network in the 8 African partner countries. She is passionate about the development of space science and technology and involved in a number of endeavors to bring that to the rest of Africa. Carla, over to you.
Hi there. Thank you for taking the time to listen. So I'm going to talk you through the Africa program, which is made up of more than just the AVN program. And I may move a little quickly through the slides. I apologize, but I'm happy to share them if you'd like to see them in more detail later. So astronomy, I'm sure you all know why we're involved, and the benefits of astronomy and radio astronomy in particular. But this has special reference to our African partner countries. These are countries challenged by many provisions of basic resources and many other challenges. So astronomy and the space sciences are a difficult why to answer. Something we've been focused on in the Africa program is developing institutional capacity and the human capacity development side of it, not just in the hopes of creating employment, but creating qualified scientists that can perform science within their own countries and developing scientific returns, along with technology development and bigger aspirations. So as you all know, Meerkat was inaugurated in July 2018, and we are currently busy with the Meerkat extension, as you know. And the SKA International is moving ahead, having signed the IGO, the treaty for the organization. Why I bring this up is the whole idea behind the AVN was preparation for SKA phase 2, the outlying or remote arrays that would come with later versions of SKA. And phase 1 is due to start construction in roughly 2022. And this is significantly delayed from the original idea. So we've had to come up with, which I'll address later in my presentation, science and capacity building programs that can fill that interim towards AVN and develop standalone programs outside of just SKA preparation. So to date, 145 grants have gone to our African partner countries and 157 if you include technical bursaries. They've been fairly distributed, and we've had very good performance from our African partner country students. One challenge, though, that is faced within our African partner countries is once students graduate, is where do they get employed? It's a challenge. They go on to do further studies overseas, postgraduate studies. And the challenge is how do we keep them employed and doing science in the countries where they're from? Through this period of the pandemic this year, obviously travel wasn't allowed, and it's been challenging resource-wise and otherwise to keep things going. But a number of areas that fall within the Africa program, such as the data science intensive program, have continued. We've had a number of hackathons. The DARA training, unfortunately, is in person, normally hosted at Hartbeespoort at Hartrau. We couldn't obviously host that this year, but they provide seminars for students to participate in. And Soreo has launched its e-learning portal, and we'll be looking at doing an interferometry school through that, hopefully still this year. So the AVN, the idea between the AVN is obviously to develop an African VLBI network. I'm sure I don't have to explain to anyone what that is. And towards this, in the process, is a transfer of knowledge, development of technology skills, science skills, and collaboration through our partner countries. So I interact directly with our AVN team, which is managed by Kobus Klutter. He's the AVN program manager. I myself am an economist, not an engineer. But the larger program is looking to establish three main pillars, one being human capital development, the second being research and technology development, and the third is growing funding partnerships and policies. A real challenge when interacting between countries in Africa is either the lack of institutional capacity or the lack of funding, or perhaps policies aren't in place. So there really is a three-pronged approach to this, and developing all areas, one on the side of training and technology development and in capacity building, as I mentioned, the funding and partnerships, and then the actual infrastructure, the VLBI telescopes, training infrastructure, the high performance computing clusters that have been provided by the CHPC in South Africa, the astrophysics laboratories, and then other scientific instrumentation. So the Africa program, just reiterating these principles, is looking to implement, most importantly, I think, collaborative funding and resource models that can be sustainable in the long term. A challenge in our partner countries is it's one thing to build a telescope there, it's one thing to train scientists, but it's another thing for them to be able to resource the ongoing operations and maintenance of the site. And so we've been examining possibilities to co-locate other science instrumentation, data facilities, and now satellite receiving ground stations. I'm going to skip over that for now. So the challenge we face in each country as we go towards VLBI is as simple as electricity supply, access to the internet, having the ability to store, transport, and analyze data, and the other areas I've mentioned already. So with all that I've said, it comes together in what we call the co-location plan. Ideally, what we're looking to do is that each partner country will host a radio astronomy telescope. It will host either on the site or at the local universities, training infrastructure towards single dish science, interferometry, and the hope is ultimately to develop the VLBI training array across our partner countries. And this can be achieved by hosting, obviously, the radio astronomy instrumentation, but looking to co-locate other science instruments and other revenue-bearing infrastructure, such as satellite ground receiving stations. The benefit of a ground station is that it can be hosted and purely hosted, in which case it generates a substantial rental revenue, or the local government can participate in the ownership of the ground station and have cheaper, faster access to the Earth observation data, remote sensing data they would need to address their national problems, whether these be water management, resource management, environmental management, etc. This way we can develop sustainable revenue for ongoing programs. We provide employment opportunities, and value-added solutions can be developed. So this is looking towards a model where government, academia, and industry partner together, that they may all benefit and develop an ongoing, growing program that can bring benefit to many areas of the economy. So in Ghana, we decided to run a pilot program. Ghana was the first avian dish to be completed. It's in a last phase of engineering now. There have been substantial delays, obviously, as our teams couldn't get there this year due to the pandemic. That second phase of engineering work should be completed next year. And an arrangement has been struck with an international ground station company. Their dish should arrive in late December, early January. It will be erected and running by March. This is generating a significant hosting rental for GSSTI, the site where the radio astronomy site in Ghana. And thus they'll be able to now cover the costs of running, operating and maintaining the site. The skill set required to manage a ground station dish or a radio astronomy dish are interchangeable. So it's providing an opportunity for employment and training, additional training for the staff on site. So this has worked well as a pilot program, assuming the dish arrives safely in January. And the company is looking to put, if this works, to put more than one dish on site, which will increase the revenue potential. We are also looking to develop between them a data solution for the Ghanaians, and thus the government will be able to access faster, cheaper data that they can use for country mapping, anti-illegal gold mining, etc. So I mentioned earlier the delays and interim programs. So what we've put into process now and are finalizing is a 2-dish interferometer. These will be, originally we were looking at 3-meter dishes, but there's a potential for an international collaboration for 4.2-meter dishes that actually are able to perform radio astronomy, but also receive satellite data, and this is a new receiver that's being developed. We did implement a 2-dish interferometer in Botswana. This wasn't a very high-tech interferometer, and so we'll be looking at a much more rugged, stronger technology. And it is hoped that beyond single-dish science and interferometry, that these can actually be linked to do VLBI training between the countries. So this is a sample of the kind of dish we've been looking at. This is an Italian dish, and there is actually one at SAO. And then I come to CAT7. So most of you should know CAT7. It was the engineering prototype we built prior to MeerKAT. Obviously, once MeerKAT surpassed it science-wise, there was no further need. But we're now looking at the science capability currently in each of our partner countries and what the areas of research are, to look at the possibility of re-energizing and refurbishing CAT7 with the appropriate receivers so that our African partners can, in the interim, start using it as a remote array that they can perform science with and work towards their training programs. I thought I would just, I don't know if I had time. Sorry, I spoke faster than anticipated. Just to mention, I've had a number of questions about the Ghana science case, as that dish, as I believe, can do VLBI with the European VLBI network and with HeartRAO. But it has a science case on its own, and that would be the long-term focus on sources. So the nice new dishes all around the world don't have the time to sit and monitor sources over long periods of time. So these older, bigger dishes are more popular for this now, I believe. And of course, pulsar timing and mazes. So there could also be magnetar searches included. So that's the science case currently for the Ghana telescope at Quintinsi. And that's pretty much all I have to say. There we go.
Thank you very much, Carla, for that overview of the Africa program at the moment. We don't have any questions on Slido at the moment, so I encourage people to post them if they have. Nikki, do you have a question?
I do, actually. I was just wondering, what is the level of involvement from the partner countries in establishing this African VLBI network?
Originally, the agreements with our partner countries, they supported the bid to host SKA in Africa, with the site being in South Africa. And almost in return for that, we would develop this VLBI program in all the partner countries. So their participation is having a site allocated, putting the appropriate institutional authorities into place. Some of the countries didn't have a space agency or similar that could manage the program, and they have to provide the infrastructure to the site. Like I mentioned, these are remote sites, so they need electricity, they need access, they need fiber. So it's their portion to get the sites ready.
Okay, thank you.
Thanks, Carla. And I know Ghana was the first conversion effort by SKA Africa, by Soreo. Can you comment a little bit on the academic development in Ghana from the time before the project commenced to now? Have there been any academic programs developed in the country that support these endeavors?
Yeah, that was before my time, but I stand to be corrected. But I believe that prior to this program, there was no astronomy education at a university level, and now there are astronomy courses at universities and programs, although they may sit within physics, etc., and not standalone departments. But students in these countries can now study, in Ghana, can now study astronomy.
In Ghana?
Yeah.
Oh, that's fantastic. Well, thank you very much, Carla. We'll let you go now. That was an incredibly enlightening overview. Thanks very much.